In carbocations, we have seen there is positive charge on carbon. Similarly, if I just look at this carbon ions, so we can see here it is the anion of carbon. It is anion of carbon, and so we can say here like it must be like this C and a negative charge. Presence of negative charge is possible if it is present in this, or if the bond has been broken in this particular fashion, like see something like this take B bond is there, and this bonded pair of electron is being shifted to this carbon through heterolytic cleavage, and thus we can see this carbon has two extra electrons to accommodate, and these two extra electrons are just showing the presence of a negative charge because one of the electron is taken from B. So this is a carbon ion. Now if I just look at it, so we can find there are in total 3 sigma bond and one lone pair. Therefore total number of electron on this is 2 into 3 plus 2, so this is equal to 8 electron. So since it has 8 electrons, so octet is complete. And if octet is complete, so we can say this is electron precise. And now since it is needing, or since it doesn't need any electron, so it cannot be electrified, but having a negative charge with unpaired electron, unbonded electron, so it will act as electron rich or nucleophile. So this would be acting as nucleophiles. So we can see here like this carbon is acting as a nucleophile. Now to look at this further, its a structure. So a structural feature is if I just look at the structure, so we can see with this carbon is this carbon, one bond, another bond, and third bond is here, and one lone pair. So it is pyramidal. It is pyramidal in shape. So this is pyramidal in shape. And now how do we predict its stability order? So the stability could be predicted using, since it is electron rich, so we can say here that all those groups which are electron releasing group will again push the electron, so push the electron, increase electron density, and therefore increase in energy. Therefore we can say destabilized. On the other hand, if there is some electron withdrawing group, so in that case what will happen? It is pull, decrease electron density, it will decreases the energy, therefore stabilize. so it is stabilizing the structure or the carbon ions. So basis this, we can say all stabilizing groups are like this. Like we can say here it is minus I minus M minus R, and destabilizing R plus I then plus M then plus R. So these are destabilizing groups, whereas this is stabilizing group. So this is the concept that we can use to explain the stability order. So let us see through some example. So if I just have taken this one like CH3 minus CH3 CH2 minus, then CH3 CH3 H minus and CH3 CH3 and minus. So if we compare these, so we find here it is one methyl group, here it is two methyl groups, and in this case there are three methyl groups. So we can say here that these methyl groups are plus I groups, therefore the stability decreases. If I just write the numbers like 1 2 3 4, so we can say this is 1, this is 2, this is 3, this is 4, and so the order would be 1 is more stable, then 2, then 3, then 4. Let us again, if we take this one, like this, CH3 CH2 minus, then we have CH2 double bond CH minus, then we have HC triple bond C minus. So in these cases what happens? So here we can say in this case all these are, this is CH3 plus I, whereas these two we cannot exactly predict. So how can we predict this? So we use another concept called the concept of electronegativity, so that if I just look at it, so it is sp3, and if it is sp3, so it has 25% S character. In this it is sp2 hybridized, so this is 25%, this is in this particular case sp2, so it is 33% approximately, and in this case sp hybridized, and so it is 50%, and if it is 25, 33 and 50, so more the S character, more is the electronegativity. That is simple rule that we can use. So more S character, more electronegativity, and therefore if it has 25% S character, it has 33%, it has 50%, so we can say 50% would have more electronegativity than the 33% than the 25%. So basis this, we can say that in the case of third one there is maximum electronegativity, so pulling maximum electron towards itself, in comparison to the second one in comparison to the first one. So since it is withdrawing maximum electrons, so this is most stable. So out of these 1, 2 and 3, the order would be 3 is the most stable, then second, then first. So this is the another example that we can use. The third one, if I would have taken this one like CH3, CH2, CH2 minus, then we have CH3, CH2 minus, and we have this one, CH2 minus. To predict the stability order, what we can see in the case for this is first,